So today we will learn about the circle measurements, and let's start with recording some very basic stuff. When we have a circle with a center, that is distance from the center to the circle called. How it's called? Radius. How this line called from one end will represent the diameter. And what is the circumference of the circle?
2 pi r.
2 pi r. Area of the circle, pi r squared. Now, if we, from the center of the circle, we draw angle theta, which divides circle in two parts. How we name them? Sector. This is called minor sector. Minor sector and major sector. How we can find the area? So first, how we can find the length of arc? This is called arc. How we can find length of arc that limiting this sector as a fraction of the whole circumference, and so theta divided by, if we're talking about in degrees, that will be over 360 times 2 pi r. This is the length of arc, which simplifies to theta times pi r over 180. That is in degrees. If we take in radians, if you take n in radians, then we have L will be theta over, what is the whole revolution in radians? 2 pi theta over 2 pi times 2 pi r, which results in 2 pi cancels out, becomes just theta r. That is in radians. That is the length of arc. Area of the sector, again we can find, we're talking about the minor sector. So area of the minor sector, again we use ratio theta in degrees, theta divided by 360 times pi r squared. This time nothing can be cancels out. That is in degrees, and in radians, area will be equal theta over 2 pi times pi r squared. Pi cancels out, we get theta r squared on 2. That is in radians. That is area of the sector in radians. Now, segment. What is segment? If we have a circle, we have some sector with the angle theta, and we draw the line. How we call this line? Chord. What will be the length of the chord? If radius is r, this angle theta. To find length of the chord, what kind of triangle is that? Isosceles. It's no. It does not have to be equilateral. It's isosceles. So if we draw the height, which will divide this in two halves, and this will be equal using SOHCAHTOA, will be r. So length of the chord will be equal to, because two parts, times r times sine theta on 2. That is the length of the chord.
2r sine.
R, so this bit will be r times sine of the half of theta, and times 2 because this is a half of the chord. That's how we can find the length of the chord. Now, this called segment. To find area of the segment, we take the area of the sector and subtract the area of the triangle. And subtract area of the triangle. These, by the way, are questions with the chord, with the areas of sector, segment, highly likely to be on the exam as a part of the question, on the final exam, I mean Unit 3-4, as a part of the question, usually related to complex numbers, where you will need to find something like that. So area of the segment will be equal area of the sector minus area of the triangle. Area of the sector in radians. What we just derived area of the sector in radians?
Theta R.
No.
Oh, sorry.
Theta R squared on 2. Yeah, agree?
Sure.
Minus what the area of the triangle?
Base times height.
Base times height. Base is,
I'll put it to AB minus sign.
or the better, use another formula that we have learned, that the area of the triangle equal AB sine n between them, because this is, we know A and B, they both are. So area of the triangle will be 1/2 R squared sine theta. Area of the triangle, we have AB angle theta, area of the triangle. When we have triangle AB theta, area of the triangle is 1/2 AB sine theta. 1/2 AB sine theta. So this is the formula, if you know radius and the angle, how we can find the area of the sector. And let's consider one example. Please open your booklet on the page. Page 13. Page 13, example 3. Page 13, example 3. Two sprinklers spread water in circular path with a radius of 7 meters and 4 meters. If the sprinklers are 10 meters apart, determine the area that received water from both sprinklers in square meters to 2 decimal places. So it's always useful for such equation to draw a diagram. So we have biggest circle with a radius of 7 meters. We have smallest circle with a radius of 4 meters. And it's given to us that the distance between the centers is 10. And we need to find this area where those circles overlap. To do that, what will be the first step? What will be the first step? What we need to? We need to know the angle. To apply formulas for area of the sector, we need to find those angles. How we can find it? Using, so let's say this is angle will be alpha, this angle will be beta. How we can find them? Using what? Come on, we just, if you know 3 sides of the triangle, how we can find angle? Using what? Cosine rule. Using cosine rule. We will have that cos alpha will be equal 7 squared plus 10 squared minus 4 squared a squared plus b squared minus c squared divided by 2 times 7 times 10. And so alpha will be cos negative 1. If you substitute the numbers, we will get that alpha will be equal 18.195 degrees. Same way we can find beta, cos beta. Now you tell me what I should write to find cos beta.
4 squared plus 10 squared minus 7 squared.
4 squared plus 10 squared. Add those sides which makes this angle beta. Minus opposite side 7 squared divided by 2 times 4 times 10. And putting that in the calculator will give us value of beta equal 33.123 degrees. So we times now them by 2 because this angle is double alpha, this angle is double beta. So we have it is 36. When you double it, 36.39 degrees. And this will be, if you double 66.246 degrees. Makes sense what I did? We found the angle. Now we can apply the area because this is effectively is 2 sectors. This is 2 sectors. I will color them in the different colors so it will be more evident. It will be more evident. So that will be segment from the biggest circle, and this will be segment from a smaller circle. And we know angles, we can calculate the area of each segment and then add them up. So for that, we will have 1/2 times radius squared times 7 squared.
Wait, do you need to know the length of the chord?
Huh?
You don't need to know the length of the chord, right?
No. We adding to find area where circles overlap, we need to find area of this segment, which is a part segment of the biggest circle,
Yeah.
and segment of the smallest circle. So for biggest circle, 1/2 7 squared times 1/2 of the 7 squared times 2 alpha. And now, this is better to turn into the radians. In this case, better to find angles in the radians, and this will be equal 0.6352 radians, and this will be equal 1.1562 radians. So that will become times 7 squared times 0.6352 in radians minus sine 0.6352 and plus 1/2 we have times 4 squared times 1.1562 minus sine of 1.1562. That is, I've just used the formula of the segment which we just derived.
Are we adding them?
And we're adding them because we give one of them This will be this segment, and that one will be the blue segment, and total area will be, we add them, we put numbers, it will be equal to 2.95 meters squared. Make sense?
Yeah, but I have a question. How did you know to use radians and not degrees?
Because if you look on the formula, it is more, the formula much more simple in radians. But for the formula for the area of the segment in radians, it's just more simple. You can use degrees, you can, but it will be much easier to use radians.
Yeah.
Okay, that's all new for today. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, and so on. Support Ukraine and Israel.